Welcome back to my channel Kishore Sir Ki Pathshala. We are doing chapter Metals and Non-Metals 10th Cbse. So let's see today's topic. So let's see what happens when metal react with acid. Alright, let us see when metal reacts with dilute acid, it gives me salt and hydrogen. That we need to remember. A general reaction, that is, a metal reacts with acid, it will give me a salt and hydrogen gas is released. Okay, right. So let's collect the samples except sodium and potassium. As you know that these are much reactive metals. Let's then take metals such as magnesium, zinc, and clean them with a sandpaper as such. Okay, so why this cleaning is necessary? We have seen that what happens is that if we say magnesium, you'll see a layer of magnesium oxide is formed, which will prevent the inner magnesium from not getting reacted, right? So let's put this sample separately in different test tubes which contains hydrochloric acid, and let's suspend a thermometer into the test tube dipped into the acids. Now let's see what happens. You'll see that the bubbles will come out. Okay, the bubbles will be evolved, right? Here is the HCl and here is the metal. Okay, what you see is that you will see bubbles of hydrogen are evolved, right? Okay, so now the rate of formation of the bubbles will be different for different metals. Okay, so what we see is that which of the metals vigorously reacts with this dilute hydrochloric acid in the given metals such as magnesium, aluminum, zinc and iron. So magnesium is the element metal that will react most vigorously, right? And the highest temperature recorded will be that in case of magnesium only. Now if we arrange the metal in the decreasing order of the reactivity, what we see, that is magnesium, aluminum, zinc and iron. So this is the decreasing order of their reactivity what we see. Now let's see the reactions which takes place with dilute hydrochloric acid. See here, magnesium with hydrochloric acid, I will get a salt, that is magnesium chloride, plus hydrogen gas is evolved, right? So we have already seen how to balance a given chemical reaction, right? So magnesium chloride is what, my MgCl2, that we need to remember. Now if I've got aluminium, right, which reacts with dilute hydrochloric acid, I will get aluminium chloride. Aluminium chloride is nothing but AlCl3 plus hydrogen gas is evolved. When I take zinc, I get a salt called as zinc chloride, that is ZnCl2. Okay. In case of iron, I get a salt, that is my iron 2, right? Okay, that is my FeCl2. Okay, plus hydrogen gas is evolved. So these reactions are very important in case of balancing also. So we have already seen how to balance a given chemical reaction in the previous sessions. Now, if we see that hydrogen gas is not evolved when metals react with nitric acids as such, right? Why so? Because nitric acid is a strong oxidizing agent. It is a strong oxidizing agent. What it does? It oxidizes the hydrogen produced to what? To water, and itself get reduced to what? Nitrogen oxides, right? Like NO2, NO as such. Let's take one example of copper. Copper reacted with concentrated nitric acid, right? See a concentrated nitric acid, what product I am getting? I am getting copper nitrate, yes, along with nitrogen dioxide and water. Okay, right? Then you'll see that when copper reacts with dilute nitric acid, what I will get? I will get nitric oxide, right? And copper nitrate. So these two reactions are also very important reactions are such where what I'm getting here is that copper nitrate in both the cases I will get in concentrated, and in dilute I'm getting a different product, nitrogen dioxide and nitric oxide as such. Now if you see, my magnesium and manganese react with very dilute nitric acid to evolve hydrogen gas. Okay, the rate of formation of the bubbles was the fastest in case of magnesium, we have seen. The reaction was also the most exothermic in case of magnesium, right? The reactivity decreases in the order of magnesium, aluminum, zinc and iron. Okay, in case of copper, what I have seen, in case of copper, when I put this thing in HCl, what I see is that no bubbles were seen and the temperature also remained unchanged. So this shows that the copper doesn't react with dilute hydrochloric acid, right? Now let's see what we mean by aqua regia. Okay, aqua regia is nothing but in the Latin word it is royal water, it was called as. It's nothing but it's a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3 to 1. What it can do, it can dissolve gold, right? Even though neither of these acids can do so alone. Okay, so this is a mixture in which gold can be dissolved, right? Now how is this aqua regia all about? It is highly corrosive fuming liquid, right? It is one of the few reagent that is able to dissolve gold and platinum. Okay, you'll see that gold will not dissolve in H2SO4 alone or HCl alone or HNO3 alone, but it will be dissolved in what? In this aqua regia as such. Then let's see how do metals reacts with solution of other metal salts. Okay, so here what we are doing, we are taking one metal salts and we are taking a metal, and we are saying how this will react. Now what we are doing here, we are taking a clean wire of copper and iron nail. Okay, so I am taking iron nail, right, and I am taking a copper wire. Okay, now what I am doing here, I am taking copper wire in a solution of iron sulfate. Okay, I am taking iron sulfate here, iron sulfate solution, and I'm keeping a copper wire into that. See here, I've suspended a copper wire into this. Okay, right. And next what I'm doing, I'm taking copper sulfate solution. See a blue color copper sulfate solution, and I'm putting iron nail into it, right, into this in test tube A, for example. Right, in test tube B, what I've done, I've taken a copper wire and I've put into what? I've put into iron sulfate solution. Right. Okay. So now let's see what happens. After 20 minutes, let's observe the color, what it's happening. You'll see that the blue color of the copper sulfate vanishes. Right. The blue color, it starts disappearing. Right. Now, what I see here, right? We have seen in previous section that all metals are what are not equally reactive. So that we have seen. Okay, we check the reactivity of various metals with what? With oxygen, water, and acids. Okay, but all metals do not react with this reagent, right? So we are not able to put all the metal samples we had collected in the decreasing order of their reactivity, right? So what is the answer? The answer is displacement reaction, which we have studied earlier, right? It gives the better evidence about the reactivity of the metals, right? So it is a very simple and easy method where we see that metal A displaces metal B from its solution. Why so? Because it is more reactive than B, right? So on that basis only, so what we see here, the experiment, the activity we have conducted, In which of the test tube do you find that the reaction has occurred? We have seen that the reaction occurred in a test tube where copper sulfate was there. How we recognized it? We recognized it as the copper sulfate, that the blue color faded, right? Okay, so on what basis we can say that a reaction has actually taken place? We have seen the fading of this blue color, and that's the reason we can say that the reaction has taken place. So what we have proved, iron is more reactive than copper, right? That's the reason it displaced copper from copper sulfate, right, to form iron sulfate, right? So here is a reaction where iron is there, it is displacing copper from its salt, and you'll see the copper is formed, right? And you'll see iron sulfate is formed. So what I see here is that metal A is more reactive, and that's the reason it displaces another metal which is less reactive than it from its salt solution, and thereby a salt solution of that metal A is formed and metal B is displaced. So what I can say here is that metal A is more powerful than metal B, right? So on this basis only, we have the reactivity series. What is this reactivity series all about? So we have seen that reactivity of all metals is not the same, right? So we have also seen that the reagents such as oxygen, water, acids are not that useful to determine the relative reactivities of all these metals. As all these metals, they do not react with them. So we cannot decide which metal is more reactive than another. So the answer is what? The answer is my displacement reaction, right? Which tells me that which metal is stronger than the other. Okay, so scientists have developed the reactivity series by doing many experiments of displacement reaction. Okay, so the arrangement of these metals in the increasing or the decreasing order of reactivity is called the reactivity series of metals, right? It's nothing but the arrangement of metals in the increasing or the decreasing order of the reactivity, right, is called reactivity of the metals. So metals are divided into different groups as such. One is highly reactive metal, one is moderately reactive metal, and another is less reactive metals as such, right? So here you see the table of the reactivity series. Potassium, sodium, calcium, magnesium, these are what? These are the most reactive ones, right? Okay, then you see magnesium, aluminum, zinc, iron, and this is how the reactivity decreases, and at the end you will see that silver, gold will be there, right? These are the least reactive. Okay, so this is my reactivity series. So student, I'm sure you have understood today's topic. So kindly like, share and subscribe my channel Kishore Sir Ki Pathshala for more informative videos.